Bismillahirrahmanirrahim. Let us go into part 3 of chapter 4.6, integrating power of tangent and secant. So looking into your workbook page 243, these are the formulas that we are to look at. Some of it are given in our formula list, and after this we are to find what will be the integral of tangent power odd number, secant power even number, okay, or secant power odd number like this. The reduction formula cannot be used because it is not in our Math 3 syllabus. But first, let us look into our formula list. The integral relating to tangent and secant, what are the formulas given? So these are some formulas given to us. We need to use this formula of the trigonometric identity, playing with tangent and secant. Okay, tangent square A plus 1 equivalent to secant square. And then we do need to apply later on the formula of derivative. Derivative of a tangent is secant square, and derivative of the secant is secant x tangent x. And here there are a few formulas given of the secant square given to us already, which is tangent. Integral of secant x tangent x is secant x, and integral of a tangent x dx is ln secant x, and integral of secant x dx, which is ln secant x plus tangent x. Other than these formulas, we need to equate and solve. So coming back to this page, so basically we need to prove how do we get integral of the tangent square, which is not given. Okay, the highlighted one are the formulas given in our formula list, but tangent square x is not given. So let's do after this, okay, on how do we prove that the integral of the tangent square is this value. And after this, we are to integrate all these questions. So before we go further, there is a guideline given in our workbook, page 245. Okay, we can use this, okay, whenever we are to integrate. For example, tangent with odd power, we are to use this identity. We need to split first into secant x tangent x, and then use this identity and then use the u substitution. Okay, the appropriate u is to set u as secant. Whenever we have secant with even power, split, okay, to get this secant square, and use this identity, the formula, and set the u to be tangent and differentiate from that. If the tangent is even and secant is odd, again we have to use this identity, reduce the integrand into a function of secant only. So this is a simple guideline. After this, we're going to use this guideline. Okay, for a start, let's do the integral of a tangent square x. This is not given in our formula list, but the identity given to us in our formulas is this. So tangent square, we change it into secant square x minus 1. And the integral of a secant square is given in our formula list, which is tangent x. For this portion, integral of dx with respect to x is x. That is the answer on tangent square x. Okay, another question given from page 243 just now. How do we integrate tangent cube? Okay, so tangent with odd power. Whenever we have tangent with odd power, split the factor as secant tangent. Okay, for this tangent cube, we split first, okay, odd power, and then we have to use the identity. Tangent square is secant square x minus 1, the formula, right? And then we are to separate. Okay, for this portion, it's easy to integrate. It is given in our formula list. But for this portion here, we have now secant of even power. Okay, so secant of even power. It says split the factors of the secant square x and then set the u to be tangent x. Basically, this and this one has two solutions. Let me show it to you. So for this portion, okay, if you set u to be secant x and differentiate looking into your formula list, derivative of a secant is secant tangent. You can replace, it becomes du. So your integral of this part will become u du, right? And then as we integrate, it becomes u square onto this portion. Integral of the tangent x, you can easily read from your formula, is given to us ln secant x. So there is one answer. Okay, depends on the u that you are taken. Let me show you an alternative work for this. What if we use another u? So like this one, I'm taking u not as a tangent because I saw the secant square. This is recommended in the guideline just now. U is tangent, so differentiate tangent is secant square. Look into your formula list. So tangent x dx is du. Oh, sorry. Secant square x dx. Secant square x dx is du. So replace, it becomes u du. As we integrate all, here we get u square onto. As we substitute, it is tangent square x onto. Okay. So you might ask, so which one is the correct answer? Let's check the answers. So let's compare the answers. These are the answers given earlier. We got secant square x onto just now. Alright. But when we are changing it, playing with the identities, secant square is tangent square x plus 1. As we separate here, we have a constant number. Okay, so we have, if I put the constant at the back, okay, c is also a constant of the integrand. So this half plus c, we can call it as a big C, okay, a constant value. So there we have this value, basically is similar to this value. Okay, so this is the answer that I've got in the second solution. Let's say this is the second solution. I'm playing with the identity here. Tangent square x is secant square x minus 1. So we play around. Let's put the constant at the very back. So that this is a valid solution for the question. Alright. So in other words to say, because of that c there being the constant, I call it a big C, okay, to represent this. Basically, both answers are acceptable. Okay, that's the beauty about trigonometry and the beauty on the integral. Only if we have the definite integrand, then we can compare and get to the one solution value. Right? So that is your question number 2. Let's do more. Sorry, that is question number 1. Let's do question number 2 now. So these are the questions that we will discuss. Page 243. Okay, so we have done number 1. It has 2 types of solution. Let's do number 2 together, shall we? Okay, let us do number 2 together. I'm going to say that when we split secant power 4, secant power square, secant square, the integral of a secant square dx is given in our formula list. But be very careful here. Whenever you have like this, you cannot say this is like secant square x dx multiplied by secant square x dx. This is wrong. Cannot, right? Only if we have a plus, then you can separate. Okay, so hence, as the guideline says, whenever we have a secant with even power, use the relevant identity, split the secant square x by using identity here. This is the identity, and set the u to be tangent. So we can use this guideline. So first we need to apply the identity there. Okay, so changing the secant square x as tangent square x plus 1, and set the appropriate u. Will be a simple u substitution, u being tangent x. And look into your formula list. The derivative of a tangent is secant square x. So hence du is the secant square x dx. We can easily replace it. Now we have a plus, you can split or you can just integrate term by term. So integrating u square is u power 3 on 3. Integrating 1 with respect to du is u. And then you replace back the u. Okay, easy, right? Okay, let us analyze this question 3. We have secant power 3. Okay, so this is product basically. So if the tangent alone or the secant alone power 3 is not given in our formula list ataupun the guideline here. So basically we cannot use this guideline. And in fact, if you let's say you say, okay, I would like to change the secant into tangent such that the u is tangent theta. And if you look into the formula list, what is the derivative of tangent? Okay, look into your formula list. Okay, in our formula list, tangent is secant square theta. We need secant square. Okay, but we only have secant over there. And in fact, if you, so here in this case, the u substitution does not work. Okay, why so? Because you cannot replace everything into a simple u. Alright, so and then maybe you try it again. Let's say the u be secant, and here we have tangent square. If u is secant, so the derivative of a secant, look into your formula list, is secant and tangent. We need secant tangent. Over here we have tangent square if we are splitting it. Okay, so another way to say here, the u substitution method does not work. Okay, does not work. So we have to look at another alternative method to solve this question. So the method that we have learned so far is the inverse, and maybe here we can use the integration by parts, the formula. Right, you just need to recognize what will be the appropriate u and dv. When we are choosing the dv, make sure it is something that can easily be integrated. And in our formula list, we have an integral of secant square is given. So this part is easy to integrate. So that is a technique. Okay, so we split first u as secant, and we are to choose dv, something that is easy to integrate. So we choose secant square. As we integrate secant square, look into your formula list. Secant square is given in our formula list, which is tangent. Okay, easy enough. And the differentiation of a secant is secant theta tangent theta. Right? So the formula, okay, put into the formula u, the v minus v, and du is secant theta tangent theta. So we are left with tangent theta secant theta. Alright, so for this part, maybe you can use a simple u substitution or multiplications of tangent square and secant. We can use a guideline. Let me get the guideline. So this is a guideline. Whenever we have tangent being even, okay, and secant power 1, use this identity to change, reduce into secant, and then try to use a simple u substitution maybe. Okay, alright, why don't I leave this part for you. Okay, let me give you about 5 minutes. Everybody try of your own so that you can fill the question. Okay, afterward we will compare answer. Ready? 5 minutes from now.